So defining IP address is the main functionality of network layer. So what we do in defining IP address is we assign a logical address to every machine, and that is a unique identifiable address for that particular machine. As we all know IP addresses, because till now we are using these IP addresses very frequently. But today we will see in details about how these IP addresses, what are the different classes of IP addresses, and what are the advances in the IP addressing scheme that we will look into details. Right. So IP address is a 32-bit address that uniquely and universally defines the connection of a device. So this particular can be for the computer, for router, for laptop, for mobile. So for every device there will be IP address whenever it is getting connected to a internet, and for the communication purpose the IP address is must for all the devices. IP address is 32-bit long. It is a unique and universal address. So the total address space for IPv4 addressing is 2 raised to 32, right? So these many, the huge number, that is 4294967296, these many number of IP addresses are available universally with us. These are the total number of IP addresses available from given address space. The address space is of 2 raised to 32. It's that much huge for IPv4 addresses. So how these IP addresses are noted? So they are noted with a dotted decimal notation and a binary notation, correct? So we have 128.11.3.31 is one of the IP address. Now this IP address is represented in a binary format also, a dotted binary notation. In that dotted binary notation, every every digit is converted to binary format individually. That is our dotted decimal notation, correct? So now there are few examples. The examples is, see, this is we are having the binary notation, and we need to convert it into decimal notation format, correct? So what we do, each 8 bits are replaced with the equivalent decimal number, and we add dots in between them for the separation. How does we do this? So as we all know that it is done with the 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5. Like this we will be representing all 8 numbers. So whichever bit, whichever locations bit is 1, it will be multiplied with that particular power of 2, and then all the numbers are added and they get converted into decimal format, right? Similarly, we can convert the decimal into binary format as well, correct? So now what are these classful addressing? See, IP addresses when started few decades ago use the concepts of classes, correct? So this classful addressing is old concepts, right? In mid 90s we get one more concept, which is a classless addressing, correct? That classless addressing supersedes this classful addressing. So now today we will be looking in details about the classful addressing and classless addressing both, correct? Now what is this classful addressing? In classful addressing we have 5 total classes. Classes are A, B, C, D and E. So let's look into these all 5 classes in details. Now look at the screen. This complete image will be helpful for us in notation, for the notation of the classes and how the classes are getting differentiated from each other, correct? Now look at this first image, which is a binary notation, the image A, which is my binary notation, correct? Now what does this binary notation says for the image A? As you all see from the screen, my first byte, when my first bit of first byte is 0, right? You have a complete address, as I already said. In a IP address we have 4 bytes. In a 4 bytes, out of those 4 bytes, when the first bit of first byte is set to 0, it means that that particular IP address belongs to class A. Understood all of you? The class A notation. When I go to class B, the first byte, from the first byte, first 2 bits will be 1 0. Fine. So that is my class B address. For class C address, from the first byte, first 3 bits will be 110. For class D, it is 1110, and class E will be 4 times 1. You can see that these numbers are all prefix notation. No number is a prefix of another number, right? Are you finding this 10 at the start of any other address, C, D, E? No, even we are not finding 0 also at the start of any other address. So there is no confusion for defining the, or for relating the class of given IP address. Understood, all of you? So this is going to define us 5 classes. What we are looking into? We are looking into classful addressing. So in classful addressing, there will be A, B, C, D, E classes. So from these all classes, what we do is we define the range of these classes. From defining the single bit as a fixed bit, we define the range for these classes, right? So for class A, my first bit will be 0, class B 10, class C will be double 10, class 3, D will be triple 10, and class E will be 4 times 1. Similarly, when I go for dotted decimal notation, for class A, my first byte is 0 to 127. Class B is my 128 to 191. Class C, my range is 192 to 223. So what does this ranges says? What will be the first byte of this class IP address? So whenever I say that this is particularly is a class A IP address, then my first byte will be in between 0 to 127. For class B, it will be between 128 to 191. For class C, 192 to 223. Class D will be 224 to 239, and class E will be 240 to 255. So these are all the binary and dotted decimal notations for different classes. Correct. So this is my classful addressing. I hope you understood the classful addressing. So let's go with address space. So address space and this, so number of blocks. So what are the number of blocks and block size useful in IPv4 addressing? So for A, I have 128 blocks because 0 to 127, and my block size is total block size is given as a huge number, and my application is for unicast IP addressing. Correct. Class B is 16384 will be my block size, block number of blocks. Then block size is 65 536, and then application is unicast. Similarly for class C and class D as well. Correct. Now let us look at the occupation space, this address space, how much it's occupied. A complete out of a complete address space. What is my complete address space? My complete address space is 2 raised to 32, as we have already seen. How it is 2 raised to 32? Because I have my IP address is of 32 bits. Correct. So what are the different combinations available in these 32 bits? So different combinations are 2 raised to 32 combinations. Am I right? So so what does it mean? 2 raised to 32 address space is available for me. Correct. So out of this 2 raised to 32 address space, my class A occupies 50% of address space. Fine. Class B occupies remaining 50%, class C remaining for 50%, and D and E will be occupying the last remaining 50%. Correct. So like this, you can see how these classes are getting occupied. Correct. So why so? Because class A may only the first bit is fixed, right? Zero wala bit fixed है, first bit of first byte. Remaining all 31 bits are variable bits. Correct. So my class A occupies 2 raised to 31 space, which is my for 50%. Now in class B के first 2 bits will be fixed, right? 10 bit fixed था class B का, right? So out of this 10, then the remaining 30 bits are variable. We can have a combination of addresses from remaining 30 bits. Fine. So my occupancy of class B is 25%. I hope this is clear with all of you. Similarly, for class C, my first 3 bits are fixed 110, right? मैंने अभी पढ़ाया था ना आपको कि first 3 bits are fixed 110. All remaining bits can vary, correct? So those remaining bits are 29 bits. And thus my occupancy for class C is 2 raised to 29, which is 12.5%. Now for class C, first 4 bits are fixed, that is 1110. So remaining 28 bits are variable and which goes to 6.25%. Similarly for class E, again I have 2 raised to 28, which is 6.25% occupancy for class E out of total address space. Correct? So again the same the repetition of what we have seen. So class A first bit is fixed, class B 10, C 110, D 1110, E 4 times 1. Similarly in dotted decimal the range for class A is 0 to 127, class B is 128 to 191, then 192 to 223, 224 to 299 and 240 to 255. Correct? So these are my classes notations. Correct. Now there are masks which are available in the classful addressing. What do you mean by mask? The mask is my see, with the mask we are able to find the network address. Okay, so that's the reason we have a mask for each class. Now what is the concept behind this mask? I will let you know. This is what is the concept behind my mask. Correct. For class A, my network ID occupies first byte and my host ID occupies remaining 3 bytes. Right. So let us go into detail what is this network ID and host ID. Correct. So the class of IP address is used to determine the bits used for the network ID and host ID and total number of networks and host possible in that particular class. Understood? So what does it mean is I have a complete network. Say, take an example of, say you want to start up a new institute or new organization. So a complete organization is going to have its own network. So there will be one particular network mask for that organization. And all remaining PCs are host in that network. अंडरस्टूड ऑल ऑफ यू कि आपको एक ऑर्गेनाइजेशन सेटअप करना है तो माय ऑर्गेनाइजेशन विल हैव अ सिंगल नेटवर्क फॉर अ आउटसाइड वर्ल्ड and my all the PCs from that particular organization are connected to a particular network. Correct? So all the PCs or all the workstations, routers, PCs, laptops, mobiles, whatever are there, they will be my host. Correct. So I will have one network and from one network there will be multiple hosts which belong to that particular network. And that's the reason say class A में क्या है कि first byte है, first byte will be my number of networks and remaining all 3 bytes are my host IDs. इसका मीनिंग क्या हुआ है कि सपोज आई वांट टू बाय अ नेटवर्क सो लेट्स से आई गेट अ नेटवर्क एज which starts as say 22.0.0.0. So this is my network. Now in this 22.0.0 network, I can have multiple hosts or multiple machines or multiple workstations attached to this particular network or which belongs to this particular network. So all the machines which are connected to this 23.0.0 network will be having the IP address which is starting as 23 and then the remaining 3 bytes will be getting varied over there. So all the host, the host which will start from 23.0.0.1 to 23.255.255.255. These many number of hosts can occupy in this particular network. So 2 raised to 24 hosts can occupy a space in one particular network. इसका मीनिंग क्या हुआ कि एक नेटवर्क को 2 raised to 24 machines or workstation can be connected. How do I say that? Because in class A, the first byte is my network ID byte and remaining 3 bytes are my host ID bytes. correct? So this particular network id byte, one particular network will have these many number of hosts. How many number of hosts? 2 raised to 24. Why 2 raised to 24? Because one byte is 8 bits. So 8 into 3 is 24. So 2 raised to 24 number of hosts can be connected to one single network of this class A address. Fine. Similarly, class B. The class B structure is first two bytes are network IDs and next two bytes are host IDs. Correct. So class B में we have these many networks. How many networks? See, first two bits fix है आपके, right? तो remaining कितने bits हो गए दो byte में से? फर्स्ट बाइट के फर्स्ट टू बिट्स फिक्स है क्लास बी के, तो रिमेनिंग कितने हुए? 6 हुए फर्स्ट बाइट के, एंड सेकेंड बाइट के कितने हुए? 8. सो 8 प्लस 6 इज 14. सो 2 रेज टू 14 होस्ट नेटवर्क्स आर अवेलेबल इन क्लास बी. कितने? 2 रेज टू 14 नेटवर्क्स आर अवेलेबल इन क्लास बी. And how many hosts are available in class B per network? 2 raised to 16 hosts are available per network in class B. Now let's go for class C. Class C के कितने bits fixed थे? First 3 bits fixed थे, right? अब class C में network ID belongs to 3 bytes, right? 3 bytes के लिए network ID है. So 3 bytes कितने होते हैं total? 24. उसमें से 3 first bits चले गए, so 21. So 2 raised to 21 number of network IDs. तो networks, so किसका meaning क्या हुआ? 2 raised to 21 number of networks are available with class C. And how many hosts can be available for per network? 2 raised to 8 hosts per network. Correct? So let's go back and look at this. So this was that classful addressing का default mask. करेक्ट. सो डिफॉल्ट मास्क में क्या होता है कि आपका जो नेटवर्क का पार्ट है, नेटवर्क का पार्ट वी सेट ऑल टू 1 एंड होस्ट का पार्ट वी सेट ऑल टू 0. Understood all of you? So the network mask for class A is 255.0.0.0. For class B, the network mask is 255.255.0.0. For class C, the network mask is 255.255.255.0. Correct? So these are the default mask for my classful addressing. Correct? So now whatever I said, let's look it pictorially. Correct? So network, देखो अभी ये class A, what it is written for the figure? Blocks in class A. तो क्लास ए में नेटवर्क आईडी 0 है, नेटवर्क आईडी 0 है. तो देखो आपके ये होस्ट कितने हैं? होस्ट विल स्टार्ट फ्रॉम 0.0.0. टिल 0.255.255.255.255. सिमिलरली नेटवर्क आईडी 1 के लिए अगेन इट विल वेरी सेम. नेटवर्क आईडी टिल नेटवर्क आईडी 127 के लिए सिमिलरली इट विल वेरी, राइट? सो व्हाट डज इट मीन? 128 blocks of 1677 addresses in each blocks, which belongs to 2 raised to 24. For classes, now look it again at pictorially. Correct? So ये देखो यहाँ पे क्या दिखाया है आपका? What is my network address? यहाँ पे लिखा है देखो network address पिंक में. It is 73.0.0.1. So whatever machines are attached to this network will have the IP addresses starting from 73, and it will vary from 0.0.0.1 to 255.255.255. Correct? Now again this, see, look at here. So network ID 0 है, network ID 73 है, network ID 127 है. So like this class A में multiple network IDs होंगे and they will be elaborated like this, which is given in yellow color. Correct? So now what it is written, you can see here, millions of class A addresses are wasted. Okay, now we will come to that point again. So class B, again same, network ID 128.0, 128.1, then up to 191.255. And in that, in every network ID, we have 65536 addresses because it's a 2 raised to 16. Correct? Now look at class C. क्लास 3 अगेन सेम 192.0.0 से नेटवर्क आईडी स्टार्ट होता है अप टू 223.255.255.255. करेक्ट. सो ईच नेटवर्क or each block will have 256 addresses. Correct. So now look at this class C, class D, which is used for multicasting, and then we have a class E, which is reserved for special purpose. Correct. So now let's see. When I say that the address is wasted in classful addressing. करेक्ट. यू मस्ट हैव सीन कि क्लास ए में बहुत सारे एड्रेस वेस्ट होते हैं, क्लास बी में बहुत सारे एड्रेसेस वेस्ट होते हैं, क्लास सी में होते हैं एंड क्लास डी में होते हैं. आई हैव सेड दैट स्टेटमेंट, बट हाउ दैट स्टेटमेंट इज ट्रू. करेक्ट. व्हाई डू आई से दैट द एड्रेसेस आर वेस्टेड इन क्लास ए बी सी. करेक्ट. सो लेट्स टेक एन एग्जांपल. करेक्ट. If a company wants say 1 lakh IP addresses for their network, like now class C won't cut it since class C can allocate only 256 addresses. Wherever. Then similarly class B, since it can allocate 65,536 addresses. करेक्ट. तो वो भी 1 लाख से कम है. सो वी शुड गो फॉर क्लास ए नाउ. करेक्ट. अभी क्लास ए में पर नेटवर्क कितने एड्रेसेस हो सकते हैं अलोकेट? 16 lakhs. No, sorry. 1,67,000. 1,67,77,216 addresses. Correct. These many addresses can be allocated to one particular network ID. Right. So these many number of crores number of hosts will be accommodated in one particular network in class A. अब हमें कितने चाहिए? हमें तो 1 लाख ही चाहिए. तो बाकी बच्चों का क्या हो गया? So remaining all IP address are wasted. Are you understood? Are you getting this concept? Why there is a wastage of IP addresses in classful addressing? Again I will repeat कि you just take a simple example कि आपको requirement है organization की. I have thought of starting an organization and my employee strength will reach to 1 lakh after 10 years. ऐसा मेरा एकदम vision है. Right. So what I will think of, I will go to service provider and will say that I need a service where 1 lakh users can be accommodated. Network address where 1 lakh host can be accommodated. Correct. अब क्लास सी का प्रॉब्लम क्या है? क्लास सी में पर नेटवर्क कितने होस्ट होते हैं? 256. राइट. वाई 256? बिकॉज होस्ट आईडी के बिट्स कितने हैं क्लास सी में? ओनली 1 बाइट इज देयर फॉर होस्ट, दैट इज 2⁸. सो 256 होते हैं. तो क्लास सी तो ऑप्शन है नहीं मेरे लिए. देन आई गो फॉर क्लास बी. व्हेन आई गो फॉर क्लास बी एंड नेटवर्क एड्रेस फ्रॉम क्लास बी, तो एक नेटवर्क एड्रेस को एक नेटवर्क में कितने होस्ट हो सकते हैं क्लास बी के? 2 बाइट्स है ना. सो 2⁻16. सो दैट कम्स टू 65,536. माय रिक्वायरमेंट इज ऑफ 1 lakh. सो आई हैव टू गो टू क्लास ए. नाउ व्हेन आई गो टू क्लास ए, पर नेटवर्क मेरे कितने होस्ट हो सकते हैं? 2⁻24, which goes in millions, which goes in crores, right? But my requirement is in lakhs. मेरे ऑर्गेनाइजेशन के लिए मेरा रिक्वायरमेंट 1 लाख में है, लेकिन मजबूरी आए सर्विस प्रोवाइडर विल प्रोवाइड मी 1 नेटवर्क एड्रेस. Correct. That has to be there. That one particular, at least 1 network has to be provided to one organization. So remaining all IP address will be just waste. They cannot be reused. All remaining IP address will be wasted in this case. So now you must have got a picture of how these IP addresses in classful addressing scheme are wasted. Similarly, if I go for say a small school which requires only 10 IPs or 10 hosts, कोई छोटा सा स्कूल है, प्ले ग्रुप वगैरह है कुछ, तो प्ले ग्रुप, नर्सरी एंड देन से जूनियर, सीनियर, केजी. Now for this much they don't require many pieces, right? They just require 10 pieces. Now for this 10 machines, and if I go for a network of these 10 machines, I must allocate a network ID. When I go for allocating a network ID, I go for class C. क्लास C में तो 256 है, उसमें से सिर्फ 10 यूज होने वाले हैं. करेक्ट. इसका मीनिंग क्या हुआ? 246 होस्ट आईडीज विल बी just waste. So this is the reason I say that in classful addressing, large part of available addresses were wasted. Correct. So classes were extremely wasteful because end user requirements needed to be rounded up to the next largest class. A requirement for the 1000 IP addresses was allocated a class B network, removing 65536 addresses from the pool. This is waste of 98% of IP addresses from that particular network. So I say that there is a huge wastage of IP addresses in classful addressing. Understood all of you why there is a huge waste of IP addresses in classful addressing? Correct.